Hi, this is Habiba. In this session, we are going to create and run our measurement model in Smart PLS version 3.2.9. These are our constructs. Let's find out what are the exogenous and endogenous construct for our study. This GW and ED will work as an exogenous or independent variables, and they are called as exogenous as they have been explained by some other factors or affected or created by some other factor outside this model, while SI and II will work as a mediator, and they behave both as an exogenous and endogenous variable as they as they themselves affected by GW and ED, and they are also affecting WE, which is a final endogenous construct. So the first step in evaluating PLS SAM results involves examining the measurement model, which differs for both reflective and formative constructs. And there are difference between evaluating the reflective models and the formative models, because the main difference is that in reflective model we will go for the outer loading, while in case of the formative model we will go for the outer weights. And if the measurement model will meet the required criteria as per the guidelines, which are the rule of thumb, and if they met these guidelines, we will go for the structural model as per here at all. And these guidelines, they always depend on the context of the study. For example, in case of exploratory study, the internal consistency reliability threshold is zero point 0.6, or is minimum zero point 0.6, or maybe higher, but the threshold is zero point 0.6, while in case of the research where we are working on the established concepts, the required threshold level is zero point 0.7 or higher. And so the final step in interpreting the PLSM results involve running one or more robustness checks to support the stability of the results. But always remember, the relevance of these robustness checks depend on the research context, such as what is the aim of the analysis and the availability of data. So we will start creating our measurement model. Keep in mind all these things. Let's start with the connection of these variables. Let's choose the connect variable tool. So we will first connect GD directly with our endogenous variable WE. Likewise, we'll do the same thing from the other exogenous variable ED to WE. This is our direct path. Now we will go over the indirect path. So indirect, there are two indirect paths for GW, from SI toward GD and from II. GW will also affect through II, and IED also affect through SI. Always remember, in Smart PLS, when our model will be complete, these constructs will change the color. Usually default color is blue, but you can select the color as if you want to differentiate between endogenous and exogenous variables or little constructs. Now what we have to do, we have to run our PLS algorithm, and we have to find out, and there is guidelines and criteria for evaluating those results. And especially we have to remember that in case of the measurement model, we are more concerned about this outer model, which consists of the latent construct and its respective indicators or items, which are obviously observed variable, while our construct is unobserved variable, and this construct is reflecting itself through these observed variable or indicators or items or questions. So this is our outer model, while the paths between the constructs, all those paths, they are making the inner models, inner paths, inner model. But right now we are more interested in evaluating for our outer model. Let's go to calculate option. We have the first option for PLS algorithm. Let's find out what is the PLS algorithm. PLS path modeling method was developed by Volt in 1982. The PLS algorithm is a sequence of regression in terms of weight vectors. The weight vectors obtained at convergence satisfy fixed point equations. So we find more robust uh, algorithm measure for our reflective model. Let's find out what's the other option. We have another option for consistent PLS algorithm, which is more robust as compared to the PLS algorithm. Consistent PLS algorithm performs a correction of reflective constructs correlation to make results consistent with a factor model. As you know that the reflective model is a common factor model, and as a consistent PLS also perform a correction of reflective constructs correlation to make results consistent with a factor model. So we will go for the consistent PLS. Let's find out what are the options. In the basic setting, you need to connect all latent variables. Let's go for the partial least square. Okay, as we are concerned about the outer model, we will go for the factor scheme first. And what are the maximum iteration? Let's find out. This parameter represent the maximum number of iterations that will be used for calculating the PLSM results. So as we know that the significance of one of the significance of PLSM is that the PLSM will work on the small sample size also, but it will give you the maximum iteration up to 300, and it will assume that your maximum iteration is 300 even if your sample size is low. This number should be sufficiently large, that is 300. When checking PLSM results, one must make sure that the algorithm did not stop because the maximum number of iterations was reached, but due to the stop criteria. Here we have the stop criteria, it's a 7 which is on default. The PLS algorithm stops when the change in the outer weights between two consecutive iterations is smaller than this stop criteria value. That is the maximum number of iterations is reached. So we need to we put this stop criteria at default 7, and we have to find that find that the which is the what is the maximum number of iterations when the difference between the outer weight between the two consecutive iterations will be smaller than this stop criteria. For this we need to run the our PLS algorithm. Here we have a dialog box for open report, leave calculation dialog, open or close the calculation dialog. We will put it on default for open full report, and then we will go for this start calculation. So it's quite easy. Within a second you will get the results. Now as per the here at the first things we need to check in our measurement model is outer weight in case of the formative model, while outer loadings in case of reflective model. And the thing we need to check is that you can check the latent variables scores are also there, but we are interested in outer loadings. Okay, and the thing we need to check is the stop criteria. We need to check whether this stop criteria is less than the maximum number of iterations or not. So its iteration is 19, so it means we have met this standard, and our PLS algorithm has stopped before reaching the maximum iteration. Now what other things we need to, the second thing we need to check is construct reliability and validity. Here which is measured by Cronbach alpha, rho A, and composite reliability, out of which the rho A is the most approximate measure of both internal consistency reliability, and it lies between Cronbach and alpha and composite reliability. The threshold or the recommended level is 0.708 or above for all of them, and AVE will give us, which is average variance extracted, will give us the convergent validity of the construct. Then we need to check the discriminant validity also, which is measured by Fornell criteria, cross loadings, heterotrade monotrade ratio, and this heterotrade monotrade ratio Hansler 2015 is give most robust result as compared to the Fornell criteria that we will discuss in the interpretation section. Now you can check here VIF, that is we usually check in the structural model. The VIF values, the threshold for the VIF is also less than 5. It should be less than 3, because sometimes the values approaching less than 5 also show that there is collinearity issues among predictor variables. So the desired level is 3 or less. Here we have all the values less than 3, and we will discuss this in interpretation also. We can check the model fit also, and the model fit give us the SRMR value, which I'm more concerned about. NFI is also good. So, and we can check the R square values also, and the R square value, we are concerned about the R square value of our main exogenous construct, which is WE, which is 41.6%. And you can check the F square value also. The F square value which shows that whether the effect size of your construct for the other construct, and it shows that out of all ED has a meaningful effect and WE as compared to others. Okay, let's go to our model and discuss it over there. Here you have the window on the left side, right side. You can check that inner models are showing 5 coefficients, outer model are showing the outer loadings, and constructs inside construct is showing there is R square value, and they have mentioned absolute values for highlighting paths. First of all, by highlighting these paths, we can see that the GW has the most effect on the II, but this II mediator is not carrying forward this effect further into the WE, so there is no mediation effect in all the model. We cannot find any mediation effect. So let's go for the direct effect. There is no direct effect from GW to WE. Is the effect is very low, while in case of ED to WE the effect is good, as we can mention by the arrow. Okay, first of all, we will check for the outer model, and these indicators are the square of the factor loading, which shows how much the variance in indicators explained by the constructs, and threshold level value for this is 0.708, as we have mentioned earlier. And we can see that any of our constructs have values which are lower than 0.708. Here also we can check there are many values which are lower than that. In that case, you can do one thing. You can delete those indicators with the lower values one by one, and you can see, is it affecting, is it making your construct validity and reliability better, or is it deteriorating your values. So in case of, the thing is that in case of, as we have the reflective model, we always remember, in case of the reflective model, you are at liberty to delete or add any of the indicator without changing the meaning of the construct, in contrast to the formative model, where you cannot add or omit any indicator, because that leads to change in the meaning, or change in the that can deteriorate the estimate of the constructs. Now let's see what this value is showing. This value is showing the beta values, which shows that how much 1 unit change in GW will bring change in the II or WI. So let's find what ED is doing. Effect of ED on WE is 0.59, as we know that beta level value should approach 1. It's range from 0 to 1, and it's if the value approaches 1, it's good. And here we can see the effect, 1 unit change in GW bring about 91% change in II, but as this effect, II is a mediator and it's not carrying forward the effect towards the W, so it's of no use, and we can say there is no indirect effect, or there is no mediation effect. And as you can see, GW has also a very less effect, which is less than 6% on the work engagement. So it's a very low effect. And let's find what ED is doing. ED has 59, more than 50%, that is 59% effect on WE, which shows that 1 unit change in ED will bring about 0.59 units change in WE. So these are the beta coefficients, but when we will run our bootstrap model, we will get the significance value of these beta values. Okay, what these values inside circle show, we can see we have from here inside construct it's showing r square, and they will give you the options. You can go for the ABE. Let's find the ABE. It will give you the ABE for internal consistency for all those constructs. And if you want to go for Comback alpha, it will give you the values of Comback alpha. And here all the values are the which are requirement for the measurement model are available. If you want to r square adjusted, it will give you adjusted r square. Okay, we will go for the adjusted r square. We can see that this r square shows the explanatory power of the model for the endogenous variables or endogenous constructs. So but we are concerned about the main construct, endogenous construct, which is WE. So the r square for the WE appears 41.6%, which is quite good, as we are having cross sectional data. So 41.6% is good for the cross sectional data. Okay, and what other, and there are these values also you can change. You can either go for outer weight, outer loading, as per your requirement. Data group is complete, because we had two groups of data, and but here it's showing complete data group, the effect of complete data group. And in this session, after this session, we will go for the interpretation of the measurement model, in which we will check whether that our results are according to the rule of thumb guidelines of smart PLS or not. If we will reach to the desired recommended threshold level, then we will go for the structural model. Thank you for this session.